This is the closed containment aquaculture system phase 0.1. Inside this electronics enclosure, we have Raspberry Pi, relay module, and the Atlas Scientific pH, dissolved oxygen, and electrical conductivity circuits, as well as a 12-volt power source, and a temperature sensor inside here to monitor the temperature inside the control box. And on top we have lights and sound, and these are controlled by the relay board as well as the hardwired switches, so that they can be disabled or enabled by the farmer on the ground. So currently we have the sound disabled because it's very late at night, and the lights are enabled. The system is currently running, and we have the temperature sensors, a temperature sensor which is here inside the water, salinity, pH, and dissolved oxygen as well. Actually, these sensors are supposed to be inside this container, which is the one with the float switches, which can determine the water level. But so this is how the float switches work. They can sense the changes in water level, but because the wires are very short, so it's quite inconvenient to fill this water right now. Anyway, so this is the pH sensor. Right now it's soaking in pH 7 solution, and you can see this is the web interface. So we can see all the alerts. As you can see, the water level is empty because the water tank with the float switches is empty, and the pH is about 7, and you can see the other various values for the diff, like the temperature inside the tank, temperature inside the control box, and the time and date, and the salinity. This is in micro Siemens. Okay, so when you click on one of these, you can also see a graph of the different of the changes in values, and yep, you can do that for each one. See the temperature. Yeah, so basically what's running on the Raspberry Pi is this program, and we can see it. It takes its set of readings every minute, and right now everything is normal, everything is within range. But what we're gonna do now is we're gonna mess things up a bit. We'll start by putting the pH sensor inside an acidic solution, which is about pH 4, and we'll see very soon in the next minute that it has registered change. In fact, we can mess things up even more by changing both that and the salinity, because when we remove the salinity sensor from the water, the salinity value drops like crazy. So now we'll see. As you can see, pH change unexpected, and salinity too low, and whoa, the alarm is on. If we refresh this page, which is our web interface, we'll see that now the pH has dropped to 3.73. It is much lower, and salinity has dropped to 0, which is also much lower. And you can see on the list of alerts, salinity is too low. There's 3 alerts because it has checked three times before it has sent this alarm and activated the alarm. So and the pH change is unexpected. Right, so okay, now the alarm has gone off for some reason. Let's see. Yes. Okay, now what we're gonna do is put the sensors back into the normal position, and we'll see that after a while the alarm will go off. The alarm goes off temporarily during each reading cycle, but if it hasn't detected that the values have changed, then it will still come back on. So we'll give the system some time to check that the values have changed.